get started. And yeah, since there's only a fistful of us, let's do light intros on Mike if you got him. If not, go ahead and throw him in the chat. I'll start and goes Z, Philip, if your internet is working at this point in the day, and then we can go around. I'm Jonathan Starr. I'm the program manager of the OSI, Open Source Science Initiative. I'll do a little demo of what that is in just a second. So I won't go too deep into that. I'll just toss it over to Mike or to Z.
Cool. Zargham, I'm the chief engineer at Blockscience, and I am a member of the Scientific Advisory Council, or whatever the advisory council is called in NumFocus. I can never remember. Yeah. I'll pass it to Ryan.
Oh, thanks, Z. My name is Ryan Morton. I'm a contractor. Our company is called Morton Analytics, LLC. We do a lot of work for the USDA for their crop analysis, both on the crop side and the economic side, and also using satellite imagery to estimate crops instead of paper copy surveys. So I get to do a variety of interesting things like that. I also work with startups and get them started on their data journey and trying to monetize their data in a variety of different ways.
Very cool. I'll move the mic now. Philip, go ahead.
Yeah, hi everybody. I'm an economist at the Vrije Universiteit in Amsterdam. I've been working a lot on interdisciplinary research, primarily at the intersection between economics and psychology, but also genetics and neuroscience. And sort of like the overarching theme of that research is always big data. And so therefore, I guess I've been confronted quite a lot with the existing research practices that people have and the replication crisis that we have in many fields. And I'm generally a big proponent of open science and openly sharing data and code. And I even started a company to help us deal with some of these problems called DeSci Labs. And I'm excited to be a part of this.
Awesome. Ellen?
Hi, yeah, I'm Alan. I'm also an economist. I am a visiting research professor at Johns Hopkins, and I also work with Econ-ARK, which is a NumFocus sponsored open source platform for solving heterogeneous agent models.
Thank you. Hans Martin.
Sorry, my mouse is running out of battery. It's always hard to hit the things. Hi, I'm
right here.
I'm professor of economics at the University of Bonn. I've been using Python for 15 years now, been teaching a lot on it, and our group has produced a couple of open source projects like STMagic, probably best known, but also PyTask for running pipelines. Was a former student of mine who created that, and we're currently working on creating a library for solving discrete continuous lifecycle models. We're excited to see this here.
Very good to have you. Smit.
Yeah, hi everyone. So I'm a software engineer at Google, and previously I was working with Quanticon, which is a quantitative economics library, developing lectures on quantitative economics and high performance computing. Yeah, so.
That's awesome. Peter Hacker.
Hey everyone. Yeah, I am. My name is Peter. I'm actually a student studying scientific computing at the Technical University in Berlin. And I have also done some work at Blockscience, and yeah, I'm interested in open science, economics, all that stuff, and saw this event on Twitter, so decided to jump in.
Very cool. Glad to have you. And then Spencer in the chat says he's interested in the open source protocols and political economy as an independent researcher and writer, and written a bit about these topics. etc. He's got a link in there. Y'all are welcome to explore. All right, so this is really cool. We've got from sort of the professional side to the very academic side to the open source side. This is a great group to start with. I'm very excited for this. So first up, I'm going to do a very, very quick run through of what OSI is. Get that stacked up. Press the wrong button. There we go. There we go. So it's a non-focus initiative, the open source science initiative. We run under the non-focus code of conduct. Feel free to check that out. Basic premise, be kind. We have a steering committee of these people. I'm going to be sending these slides to y'all later, so don't worry if I go very quickly. Our main mission is to connect open source developers and scientists to fill the gap between basically open science and all the stakeholders that currently exist. We do this in a couple ways. One of them are these interest groups where we aim to connect everyone, get everyone here to share best practices, identify common pain points, and explore various solutions together, as well as talk about open source software that's being used in a specific domain. So we have all these domain interest groups that have been running for a very long time. It's very exciting to have a new one going, this economics one, and we'll probably have another one spinning up at the end of the year having to do with technology and open science. I will zoom through these except for this slide, because it's very relevant to why we're all here. We've got our two chairs, Michael Zargham and Philip Koellinger. It's very exciting to have them both as co-chairs. There are a couple other spots open for co-chairs. We like to invite as many people as we can up onto these spots. OSI is the facilitator of these groups. We do not lead them. So this is largely the last time you'll hear from me in a presentation context. I'm probably going to participate in discussions though, because all this is very fascinating. But the co-chairs really set the agenda and drive the group's direction and all that sort of thing. So the other groups, chemistry and material science, healthcare and life sciences, map of open source science, which is something I'll share a little bit about with you in just a second, and then climate and sustainability. So beyond the interest groups, we do this mapping of the open source science space, which Moss has a comprehensive proposal. Well, you can read the thing. I'll just leave that there for you. It's a very big project. This is what it currently looks like fully rendered, but ultimately you can toggle all these things individually so you can interact with the open source ecosystem in this giant database of gobs of data to see like what tools are being used in your domain of research, what tools are supported by various organizations, what's the impact of your support of a very specific tool across the map, and you can change your definition of impact based on whether you use dependencies as a definition or whether you use papers cited as a definition or whatever you want, really. It's ultimately just a giant database we're trying to build and starting to succeed at, which is pretty exciting. It's open for anyone to contribute to. We're just getting it up on GitHub. Mark, whose GitHub that is like the singular person who is doing the technical side of it. I'm the singular person that's building the database. So that's his GitHub right now. We're probably going to put it into a non-focus specific repo, but so that link might change, but you're welcome to come contribute until then. And then we also do a couple other things like Project Spotlight. So if you're an open source contributor, we'd love to write about what your project does and how it contributes to economics. Just reach out to Tim at opensource.science. And then there's a bunch of other links in here. And we would love to support any events that you would like to be involved with in open source or open science or economics. So that's what open source science is very quickly. And that's it for me. I'll pass it over to Z to really kick off the economics interest group.
Yes. So I'm looking at the agenda that you kindly assembled for us. So there's a little bit of room for slightly longer co-chair intros, and I think this is important for at least for me. I'm not an economist. I'm an engineer. I have a PhD in electrical and systems engineering from the University of Pennsylvania. I graduated over a decade ago now, so you can see the white in my beard. But I was actually focused on large-scale distributed resource allocation problems and like autonomous agents and optimization within large distributed networks with, utilities, constraints, preferences, it starts to turn out that it sounds a lot like economics. Actually, I kind of backdoored my way into economics by realizing that the class of problems that I was solving was in fact almost synonymous with a handful of operations research and broader kind of applied economics problems, some of them being better understood as policy-making problems, since they structure fields of action and intersect with industrial engineering, industrial organization being a more economics flavored variant of the engineering discipline there. And as time went on, I this led me from my PhD into an industry setting where I did a lot of OR and led some data science teams, kind of refactored some businesses, and then didn't really feel like that was what I wanted to do with my capabilities. And I founded a small private engineering firm called Blockscience. And there we've been developing out model-based systems engineering methodologies sort of as much as possible end to end with a focus on requirements engineering and sort of system level validation. It's pretty fun. There's a lot of automation happening between the kind of more sort of financial and transactional stuff happening in the Web3 world to the more kind of what I think of it as flexible and agentic stuff happening with the advent of LLMs, and honestly everything in between more traditional data science and ML recommendation algorithms, dashboards, et cetera. Fitting those together into a holistic engineering lifecycle and actually taking problems from what are effectively desired future states of the world to production information systems that deliver on those requirements. I'm also a board member and research director at the Meta Governance Project, Metagov for short, which is a nonprofit focused on the governance of digital space. I'm involved in NumFocus and a few other organizations doing open research production, Active Inference Institute as well. I'm on their scientific advisory board and contribute in some capacity if people are interested in those kinds of models. I'm going to leave it there for now, but I think I'll give a brief summary of some related research towards the end, which I think hopefully will give you a better flavor. In the meantime, though, I want to give Philip a chance to add any additional detail, since that's what is on the agenda.
No more details from my side.
All right. Next agenda item. Let's go. All right. So we have an overview of topics, and so I had some conversations with John and Philip, and so I'm going to start by sharing something that I pulled down. This is from the Federal Reserve Bank, and this is not to say that our scope is this list of items, but I think it's helpful for us to start with answering like what do people mean when they say economics? And so canonically, or kind of in an orthodox sense, we have agricultural, natural resources and the environment, behavioral econ, business economics, which I associate this closer with institutional economics since it extends beyond businesses. But I get here that we're focusing on profit maximization, which is more like theory of the firm subset of business economics, cross operations research and practice. We've got economic history, we've got economic development, we have financial economics, which again, a lot gets tied up in this. I think for some people, this topic is synonymous with economics, which is a little disconcerting sometimes. We've got health and education economics, industrial organization, which I alluded to earlier as someone who comes from an engineering background. I view it as the kind of economics complement to industrial engineering, though I do aspire to a kind of post-industrial engineering. Not everything is necessarily best fit to a model of industrial era organization, but there's a lot we can learn from that. We have international trade and finance, labor economics, got law and econ, which is another point that I would normally associate with the intersection of institutional economics. I work with several institutional economists, so the fact that that's not on here is going to keep bothering me. And then we've got macro and monetary economics, which is, I think, often an area of focus for people who kind of do armchair economics. Though I have a friend who's the former chair of the New York Fed, and I'm going to try to get her to come and give us a talk at some point in the future. Moving into computational, or excuse me, mathematical and quantitative methods, I think this is a major intersection with the computational methods. And I think, at least for my part, I would take us beyond just mathematical and quantitative into sort of computational simulations, generative models, anything that we can use to project or extrapolate, form hypotheses, run Monte Carlos. I think there's some very interesting work within our broader NumFocus community around modeling and simulation, and that merits a lot of attention, particularly within this community. Finally, we get into the public economics and then rural and regional economics with, I think, again, some interesting intersections with things like, I use this term algorithms as policy, which is the way in which existing laws, rules, policies can be thought of in the context of algorithms, and the ways in which the analysis of those policies can be rendered more quantitative or computational as a result of that analogy, but also the way that it affects our understanding of public choice problems. I'm very interested in public choice as a kind of robust optimization problem where you have not only various stakeholders, but even uncertainties in the utilities of those stakeholders. Some fun stuff there. And as I think I started to note, urban, rural, and regional economics also has some interesting intersections with things like urban planning. I'm going to continue to emphasize moving these things beyond their kind of analytical, like existing modes of economic analysis, and towards things that are more like, design, engineering, and evaluation oriented, both because I'm an engineer and because I think that that's the modality that we really need. And that as a community of kind of open scientists focusing on economics, that's the thing that we have to add to the discourse that is arguably not fully articulated in the existing literature. And again, this isn't to say that there's no policy making, there's no modeling, that there's no quantitative analysis, but more that there's room for more of it, and that actually the broader community and this open science track can help advance on that margin. And so that's my intro to the topic. I want to open the floor up and have a little bit of a discussion here about like what else people want to see within this scope.
This might be my Americanism showing, Z, but I spent a great deal of time doing rate design, both for utilities and healthcare providers. So that would be like a resource-based model. And I think there's very little transparency in the process. and I mean, just even in the American system, there lacks transparency in places like healthcare. So, I think that's one area where, systems engineering, rules, algorithms, and having them be transparent is actually a worthy area just into itself, because there's so many places where either the government or private companies are actually designing prices. And that's how we have to spend our money.
Well, and measurements and like the observability of these systems is a prerequisite for that rate setting. And so you kind of alluded to some MRV applications earlier, and I broadly see the measurement, reporting, and validation and like the development of metrics as being a dimension of economics, especially insofar as even in that list we saw things like natural agriculture and natural resources. We saw urban, rural, and regional economics. These domains necessarily intersect with things that are difficult to measure. They have to be modeled to be estimated. And the systems through which we define what and how we measure things become actually deeply entrenched in the rate setting rules, and thus the economic behavior that emerges from it. And so this is part of my justification for arguing that we need a more quantitative, computational, and a more diverse set of actors engaged within these processes. Because again, I use this kind of phrase algorithms as policy. Basically, there's a lot of implicit policy making in these systems, and this to me is the group, this kind of open science economics group is the right group for kind of extending that analysis and doing even just discovery in addition to building things. Anybody else?
I would be, as an extreme generalist in this, interested in collaborative outputs that we can work towards that will help attract people here to broaden the discussion, right? So something like Moss is very useful it's something that we can build together that we can spend 5 minutes a call and just be like, here's some open source packages that we've used in the past month. And then we put them on the map, and then we go out and show people the map and say, hey, come talk about it on these calls. That intersection of open science and economics. And then more related to economics, how is AI going to change everything? That is such a blanket statement. So I'm curious to that first point, though, to phrase that as a more direct question. Does anyone have any ideas or any needs like for a collaborative output, like anything we work on together?
Just something that I've had to deal with working with private health information, private tax information, is getting government agencies to produce synthetic data and having that sort of open data set available for innovators to work on outside of the government has been a real challenge. And you really can't know how to work within those sort of institutions without it. And I think if there were things that we could collaborate on to help agencies like the USDA or HHS or whatever government system you're working with to help them generate synthetic data sets in a transparent manner, I think would solve a lot of problems in the space where I work. But I'm not sure that's true for everyone.
It seems like that would be a very reasonable task to take on. I mean, the challenge is that you need at the very least the kind of schemas and or data dictionaries, and then you can actually create, even actually using LLMs in some cases, not that you have to, you can create models that are capable of creating rich, diverse, let's say filler that fills those schemas and produces records, and then look at the sensitivity of any software that you're building to the variances within that data. But at the end of the day, there's a piece of that isn't separable from the kind of, I guess, client in your case, use application context more broadly, which is those data dictionaries, those ontologies. Like if you don't have them, you don't even know which synthetic data to generate. But I'm happy to flag that under a cool project because it would be pretty fun. Actually, I think it might be relatively low overall effort relative to high value if we had stakeholders that we could bring into the room who could serve that function as the I call it like the domain expert from the institutions that would be served, the people who know those data dictionaries or could provide them.
I have something that I would like to bring up, but I was wondering if it would be possible to share my screen.
It totally is. It technically possible? I don't know.
No, like, can I share it with? So something we've been working within Econ-ARK very hard is at reproducibility and replications of papers. I think that's a very important topic within economics. I think econ is sort of on the cusp of becoming more professionalized in terms of our coding and our engineering, but even a lot of economists who consider themselves computational economists don't have technical training in software engineering. So we sort of pick it up as we go. And for a lot of papers that are like 5-10 years old, the way that you look into replicating it is going to a zipped folder that is part of the publication, and you have to sort of try to follow the trail of what the author did. And it oftentimes doesn't work because it probably only worked on their own computer within their own setup, and it becomes really hard to reproduce, even if they have provided the source code. And so what we've been working at Econ-ARK is trying to come up with like a set of standards, which we're calling remarks. And it's a simple thing of like, your paper has to have like reproduce.sh. So like you click, you do reproduce, and it just does the whole thing. And then you should also have citations, but you should also, very importantly, specify the environment that you're working with. There's a lot of open source econ projects even on GitHub that don't have an environment.yaml file. So like, which Python did they use, which NumPy, you don't know. You just know that at some point it worked on their computer and they have the results. And so we're working on something like this, where at the end of it, we can have a catalog of, and these are mostly our projects, of what we call remarks or reproducible objects. And what we've been trying is that you have this like description of the project, you have some metadata of who the author are, but we also want sort of interactivity. So you have this launch binder here, and you get to this thing on binder, which has the notebook, which you can click on run and reproduce like whatever sort of computational thing is on the paper. You can like change parameters and stuff like that. And at the end of the day, what we want is to be able to have sort of reproducible objects on GitHub that are very easy to set up for the end user. But they should also be easy to set up for the author. So we should have good authoring tools so that it's easy to create very reproducible projects, and good sort of reader tools so that it's easy for the reader to interact with these things. And this is something we've been working really hard on. But again, most of us are not software engineers. So we're just sort of like, maybe in some level we're reinventing the wheel. And so to that point, we would very much be open to collaboration, to feedback, to better ways to do this. But I think this is something that's been very important for us to set up. And it would be great to have more collaboration, to have more eyes on it, and to have more people that might already know how to do these things better than us. But I think for us, this is one project that we think we would be very receptive to community feedback and community collaboration.
It seems to me like the best people to approach there would be this collaboration between the data editors of the big journals, right? So are you in contact with them?
We've met with a few of them, and like I said, there are, I think Econ is in the cusp of professionalizing. There are some journals that are starting to require very, very rigid things like this sort of thing, where like it should be reproducible, not just in your computer but elsewhere. So we have taken some feedback from some sort of like the data editors. So that's been part of the agenda for this. Yeah.
I do know that there are people creating packages to make submissions to the FDA that are meant to be reproducible. That same sort of problem But they approach it in a very systematic way. So that might be another place to look at, is how are people making clinical studies available to the FDA programmatically. I work in R, not Python. So, well, I mean, I do work in Python, but I might be alone in the R world here on this call. But I do know that there's an R package that's specifically for making the entire clinical study with the data, with the method, with the publication, all reproducible and submissible to the FDA. So I know there's models for doing it. We may just have to find a way to get it to meet more where you're at.
So I think there's an important element here about again I can kind of flip this, invert it, about like the kind of economics that we can be thinking about, and that is how things get standardized, and how claims about whether things satisfy those standards gets developed. Because whether it's the reproducibility of a heterogeneous agent model built using the Econ-ARK software, or satisfying a particular data standard for a particular US agency, or ... you name it. I think that this whole idea of actors and organizations producing artifacts, whether they're simulations or data sets or software or anything really, the economy in a post kind of digital age has a very different shape, and data or metadata about things that are, I guess, either are or are not themselves just data ends up become really important. So I was going to throw the floor to Philip for a moment, because I know some of his work revolves around this concept, and then I think we should switch into, I have a short talk that I threw together at John's suggestion, talking about some of my work and focus, but really just to help seed the session, to seed the interest group. So I don't know, Philip, you want to chime in on this problem?
Sorry, what did you exactly want me to chime in on?
Oh, this question of, you just don't have to, but I was this question of data sets and code and their attributes and the way in which they become, we get standards, or we get ways of wanting to say, hey, this is reproducible, or it has been reproduced, or hey, this satisfies a set of requirements put forth by this agency. So I'm kind of interpolating between what Ryan was talking about and what Alan was talking about, and saying like, well, actually in the realm of open science, in the realm of economics at scale, we're experiencing this problem of, well, who published what, and does it which standard does it satisfy, what is it usable for, and kind of as claimed by whom. And I see this both from the journals saying this particular model is reproducible, but also say government agencies saying, hey, this data satisfies our standard, which was the two examples that we just got from our interlocutors.
Yeah. I mean, so there isn't really that much that I can add to that, other than that my conversations with people like the data editor from the American Economic Review and other people have revealed that this is not only a technical problem, but it's also a problem of organizing who is actually going to do the checking of these things. So the AR, for example, they're really struggling with this. So in the past, they have basically subsidized their data editor and the reproducibility work that his team has been doing through submissions to a database, but that database now actually doesn't generate that many submission fees anymore. So it raises this big question. So how are they actually going to keep up that standard in the future, and who is actually going to pay the salaries of these PhD students and postdocs that are actually doing all these reproducibility checks? Yeah, we're just going to leave it there.
Yeah, that sounds great. So we're at 40 minutes in, so I'm gonna jump and do this short presentation. It's actually, I actually thinned it out a little bit from the earlier plan, because I figured we wouldn't want to spend too much time in this. So let's see if I can get this open. And
When you're bringing it up, I'll point out that Victor in the chat brought up economics and policy as a potential future topic for this conversation, for this group.
yes, definitely agree with that. Can you see my screen? It should say economics of data, a teaser. Cool. Okay. This is literally just going to be an overview of some concepts. So the first thing here is like, what do we mean by data? This is obviously not what everyone means, but I've found myself dealing with a lot of problems around everything from data sets to algorithms that process data to implementations of those algorithms existing in, say, microservices, to sort of non-trivial very differences between things that are, say, tacit, like understanding arguably is tacit versus anyway, I'll just go over this briefly. It comes from a forthcoming piece from two of my team members and builds on a lot of existing literature on information management systems and definitions around it. But ultimately, the goal here is to say that, look, we've got data. It's the serialized, storable, or transmittable stuff. Basically, you can put it in a database. You can put it in a payload and send it to someone, and they get it on the other side. It's the thing they get. But a lot of the times, people substitute the term data and what's called source data here, where it's raw. Now, raw is a somewhat relative term. If I'm pulling data off of a literal sensor and then running it through a sensor decoder, then I'm going to take it from its sort of unintelligible form and make information. So now that I have, say, a time series of velocity values, again, roboticist, I'm like, that's going to be information. I might further incorporate that with a bunch of other information into, say, a dynamical systems model to form a belief. Maybe I'm doing state estimation, something like forming a complex set of beliefs about the state of the world in my model, something like understanding. Then in my and a robotics conception is closer to system identification. I'm learning parameters. I've synthesized something that allows me to make sense of not just what the current state of the world is, but like what might happen in the future. No strict guarantees, but a system identification brings you much closer to an understanding of how the world works, not just knowledge about the current state of the world, not just information, which is, kind of an interpretable version of some sense perception or data, source data, which in this case is effectively the raw pre-processed sensor data. And then ultimately you actuate on the decisions. You make decisions as a function of your understanding, but also as a function of some decision context. So you have an actuator, but you also have something you're trying to accomplish or you hope to be the outcome of your decision. And that is really requiring some measure of understanding in order to connect what you're doing to what you're hoping will come about as a result of what you're doing. So bearing in mind here that I'm thinking about this with a mostly formal decision making in an automated system sense training, I think there are interesting ways to think about what that looks like when you're running a business. Again, having helped build and rebuild some operations and automation systems within business contexts, I've had a lot of success with reasoning about organizational systems with a similar set of concepts. I'm not going to read this thing to you. It's more of a pin. So I'm doing some work right now on data markets, particularly interested in the way that those markets are structured by like a prosumer-like model. So I think of them like power grids or like, physical supply chains where you're doing collection, production, transmitting things through a network. And so, here's a visualization that is, related to, I don't think it'll end up appearing specifically in this, but there's some similar diagrams in this forthcoming paper. It gives you a sense of this kind of supply chain dependency model where in any given time, you're going to have processes that ingest data from external sources. They, go to any number of subsystems that are themselves data processing. They, compute over and produce data. And even insofar as this is not a bunch of different databases, you can think of it as local state. Again, coming from a kind of distributed robotic system, distributed dynamical system setting, it turns out that it can be really helpful to think about this in terms of the state being partitioned across a wide number of actors, both within an organization and between organizations. So in this model, I have nodes that basically represent processes with domains and codomains, and then they can have conditional logic kind of rules that you could think of as like the API access rules. And you end up with this big complex web, but it could also be how you think about architecting a software service made up of a bunch of microservices, or even in a serverless environment where you have more or less lambdas and you're just having these input output processes, and you wire them up and kind of figure out where the inflows, the sensors, and the outflows, actuators land, and then that system is wired into a larger system. And I like this particular view because it invites a sort of network formation game view of, again, if data is the thing we're thinking about the economy of, then there's actually going to be a question of, well, do you know what other API access points or data sources are out there? And then if you know about it, then you could have a sense of a positive or negative utility over it. So like, do I want that data? Is it worth making the effort to connect to it, to integrate with it? If I've integrated with it, am I drawing on it? Like, what are the cost models associated with connecting to and or continuing to draw flow over these models? And so then you actually start to get this interesting kind of network formation structure where any new data being provided is a sort of node, a data product or data service, and every link is a connection between them. And when you have many actors, then you can imagine that system kind of building up over time, and even some of them winking out. But this is a dynamic network which evolves over time and has economic incentives as part of its evolution. But it's interesting to see the difference between the processes which are changes to the structure of the network versus processes which were changed to, say, just like price information over specific flows, which don't necessarily imply changes in the network. So rates of flow or prices changing on a given network versus the network itself evolving. And so there's some ongoing work, actually quite a bit of ongoing work on network formation games within the Blockscience team. And I thought it was worth noting, since that's not public, there's some other work that's loosely related with the same co-author on context-dependent utility representations, which I think are much more interestingly coupled with some of the measurement and evaluation work, as well as just generally recognizing the connection to machine learning problems, because you start to see linear basis functions in these models. You start to see context-dependent valuations as a function of measurable attributes. And so this is published from 2021. It's not particularly I don't think it's particularly novel in the sense that other people do talk about this problem, but we couldn't find a particularly good canonical reference for what we were doing. And so we wrote it up and put it through a preprint server. And then, for reasons that I will shortly talk about, we didn't go through a peer review process. We stuck with our informal peer review where we had several colleagues get feedback, wrote it up, put it on a preprint server associated with the university that we were connected with. And I find this interesting because I have some other work on attention economies. And this quote comes from Herb Simon. And he basically says that in an information-rich world, the thing that really drives or dominates the scarce resources attention, which is maybe doesn't sound so amazing as an insight now when it feels obvious, but at the time, I think this was from the early 80s or like late 70s or early 80s that this claim was made. And so it's really very much come to pass. And in this work on attention economies, we've been exploring, especially in the context of more open source communities and some Web3 communities, the way in which attention ends up being the binding constrained resource. And so I think especially when we talk about the economics of data, both its production and its consumption, right? We need to think about not just the supply side, but also the demand side. Well, for every piece of information that is produced, there has to be a consumer that values it. So to kind of connect back to some of these earlier concepts, okay, sure, we have these kinds of input-output processes. Sure, there's a network formation game where different systems, human or machine, are choosing to draw on these data sources. And there are ways of thinking about the utility or the value of doing that. But then actually, are we talking about money or are we talking about attention, a mix of both? Because if you don't have the bandwidth to consume the information, it's not helping you make decisions, which takes us kind of all the way back to that initial concept I brought up, is that the data is not there for its own sake. It's because someone is making some decision somewhere and they have some, preferences about the future, some intent. They're maybe making predictions or, forming beliefs about how their actions affect future states of the world. And I think it's important to tie that back into whether you even really have the attention available to consume the breadth of information that's being produced. And as a result, we make decisions like in my case, being like, I'm not an academic. I don't need a citation count or official journal. I prefer to send, this isn't true of all of my papers. I have some peer reviewed, quite a few if you look at my Google Scholar, but in this part of my career, it makes way more sense for me to send things to people whose feedback I trust, get it, and then kind of proceed to build on it from there and periodically get peer review publications when my co-authors are, like in this case, this paper is under review because one of my co-authors is a professor who that's a big part of his metrics in his day-to-day life. And so kind of I'm going to round this out by trying to connect us back around to some of what we saw earlier today. So, these ideas of peer production as network formation are not totally new. I happen to like to draw things out this way. So this is a diagram that I had made, I guess, almost 5 years ago now as part of a contribution to SourceGrid, which incidentally, I believe Ryan also contributed to. And there's some more recent ethnography of that project that goes over some of its life cycle. But here you can see a set of activities that interact to produce the artifacts, which are Git repos. And you can sort of see actors taking actions to produce artifacts and the way in which even something as common as a Git repo can be understood as a kind of network formation game. This is some visualization in Network X from the research repo of that project. This is actually from that 2019 work, so it's not particularly recent, but you can already start to see the ways in which these graphs emerge over time. I think there are some really interesting applications of this to the broader open science development. And I think that, I set this up with the intent of saying, hey, like the math of open science is in itself a kind of mapping exercise over this massive network formation game of these peer productive acts. And so I am in particular very interested in the economies of peer production and the ways in which things maybe need to be priced in attention rather than in money, but also a non-trivial question of how that converts into money, sustainable funding, and so on. And I know I'm far from the only person in the greater NumFocus community who's really interested in how this production, whether it's open source software, open science, actually relates to, let's say, the intrinsic motivation of individual contributors, maybe the contribution of small teams that have some choice between building things that are bespoke or private versus taking the extra time to document them and make them open source, package them up nicely so they're available for others, all the way up to, big corporations deciding whether to use and whether to fund open source software versus keeping things proprietary. And so that is my sort of, I guess, primer slash, well, I think I called this a teaser. So just getting at some ideas out there. Nothing in particular in here is like the thing we're going to talk about, but it's certainly what I'm interested in. So thank you for your time. I'll stop sharing. I hope that's also interesting to some other folks here.
The parts I understood were. So you did, it was definitely a good overview. So like I wrote down peer review as a possible future topic of discussion here. I'm curious, did anyone else pull, like, what other interesting topics could we put on the list for future calls, future people to reach out to bring in to start talking about stuff?
I think the question of context and domain is very interesting to me, especially when you are working with unstructured data, which maybe isn't something that everyone here does, but like if you have like a Twitter feed or formerly Twitter feed discussion going on and trying to figure out what the context is about, the context can change based on the conversation. So I thought that was very interesting, especially when we start thinking about networks and how that can actually organically grow. People can connect things through words in an unstructured way, and it can become structured through a graph object. And so stuff like that's very interesting to me in terms of both automated systems and trying to define, like, well, what is the context of this of these data? Like, and is it the same here as it is there? No, it's often not. And so I thought that was that would be an interesting area for me. I guess 2 areas.
Try to dive deeper on those in the future. Anyone else? This is very much the level setting call for the group. So if you want to poke it in one direction or another, if there's something in particular that you want us to go out, it's largely me and Tim. I didn't introduce Tim earlier, by the way. He's the community lead at Open Source Science. So we go out, we find people to bring these interest groups. We'll talk to people you might be too busy to reach out to and start facilitating these conversations to try to get them in here to share their insights on any particular topic. So this is a great opportunity to think about anything you'd want us to talk about regarding open source and or economics or open science.
Hey guys, can you hear me? This is Tim. Sorry, I'm driving again, so I can't really speak, but nice to meet you all and happy to support this group.
Well, if you're talking about going and hunting down people, there's actually a really good book about the production of open source software. I think I want to say it's Bankler, but I'd have to go back and check. But we could do a little bit of brainstorming offline for people to go hunt down and invite, because I think there's if there's a particular interest around kind of the economics of open source, I actually think there are a decent number of people who have put some effort into that.
I would love that as a topic. Victor, go ahead.
Yeah, actually similar to that topic. I know right now there's a lot of debate on whether the AI policy should be enforced right now or not. EU take the first lead, created a EU AI Act. US is kind of lagging behind, but I think the other way you can look at it is, let the industry trying to figure out it itself first. So which is the better policy? So since it's kind of a policy regulation, maybe it's related to economics.
So I think the one thing I want to be a little leery of is going too far down the policy rabbit hole. I just got back from DC, where I was hanging out at an equitable tech summit with a bunch of tech policy lawyers. And I think the first thing that I took away from that environment, which is not my normal environment, is that there are like 0 circumstances under which there will be a kind of consensus agreement around a lot of this policy. I do think it's helpful for technologists to be part of the conversation. I think from this group standpoint, understanding and like education could be outputs. Like if we produce artifacts that are clear and legible about, what is currently the state of affairs with regards to knowledge object standards, evaluation, data quality, and how that relates to or doesn't relate to policies with regards to AI. I think there's relevant stuff that could come out, but I would be like wanting to draw a kind of a somewhat bright line between things that are like having opinions on policy and having opinions about things that have closer to ground truths that we can assert as education, technical expertise, etc., which would be useful in those discourses, because those discourses are kind of they're rabbit holes, and they're not necessarily let's call it, not necessarily very scientific in nature. They tend to be very agenda driven, and people put forth whatever facts, quote unquote, that support their positions, whereas like science as a protocol kind of puts forth, facts as we best understand them and tries to make them reproducible and tries to make them legible. And so at risk of being heavy-handed, I'm going to say like we should probably try to find and draw a line between policy recommendation and information that's like scientific, that's useful for informing that kind of decision making.
I think it's a very fair line to draw. We've got 0 minutes left. So Ryan, last thought here.
I was just saying,
Unless Philip, you
I'm glad
wanted
to
to go
see Z here, but I just want to say, like, I'm really interested in the systems engineering side of things and designing systems, implementing systems, and I hope that that's included going forward.
Me too.
I think that preference is how I ended up being a chair. Just to be clear, like if that wasn't a thing that people wanted, that I would not have been asked to be here.
Philip, you're muted. Did you want to add anything?
Well, I mean, I just wanted to add that, just like Alan, my primary interest is also in the reproducibility of science in general and in economic research in particular. And so although I think in economics, we actually do have more of a culture of data sharing and code sharing than in many other fields, also thanks to some of the policies that the leading journals have enacted. I do think that we have a long way to go to actually make it a habit and to think about. So one of the things that I would love to think and talk with you guys about are incentives and other things that may be needed to just make it a habit for researchers to basically work in the open and to share data and code. And I do think it is not only a matter of technological infrastructure, but a lot of incentives and culture.
There's a long sentence. Go ahead, Alan. Sorry.
Well, I was just going to say, as a small sort of piece of incentive that we've been thinking about is we have been in conversations with some people, like some of the board from the Society for Computational Economics. And we are supportive of starting a journal of open source economics. And I think part of our idea is that we want to make our tools good enough such that the Journal of Open Source Economics uses our tools, but also requires reproducibility at submission. A lot of the other journals, you sort of submit your paper, they review your paper,
exactly.
and they're sort of on the merits of the paper. And then once it gets accepted, they start reviewing your code to see if it's reproducible.
Exactly.
And we want to sort of flip that and make it more so like Journal of Open Source Software is about the software, not about so much the content. And so we have been in conversations with the Society for Computational Economics about trying to start just that, a journal that is about the software in open source economics. And a great way to incentivize for academics is to give them citations, but we would require, or we imagine, obviously this would have to be part of the conversation with the editors. We imagine that it would be first order that your submission is replicable right off the bat. And so that lowers the cost of like the data editors having to like hire all these people to see if this thing works. It gives incentives, and hopefully it also permeates the practices of open source and reproducibility into the community. So that, like, if something cool gets published on Joe's Econ, then a student can like make a fork, make their own edits, push it forward.
Oh, man.
And
Okay.
it's like,
so you two have a lot to talk about. I know that just based on
We do.
the features you're describing right now, Alan. I work closely with Philip on another project too. So maybe Z and Philip, we'll talk about this offline, but maybe reproduction in economics is next month's call, next month's topic. And we can dive deeper. Ellen, maybe you come in, you talk more about the journal you want to stand up and remark. Philip, you can come in and talk a little bit about the tech that you're building to enable all this stuff. And we can just kind of jam on this topic because this would be lovely to continue. Okay,
Wonderful.
cool. I've got to
Sounds
cut it. I
See ya.
gotta. Bye, guys. This was
Great
wonderful.
seeing
Thank you
y'all.
so much.
Bye, everyone.
Bye.
Bye.